Hey everybody, it's Mr. N here, and this is the next section, 3.5. We are going to review writing equations of perpendicular and parallel lines. So, first of all, suppose we have a point right here, and we'll call this x1, y1, and a point, we'll call it q over here, x2, y2. The slope of a line, we call it m. Now that's crazy that we call it m for slope, but s usually stands for something else. And you can think of it maybe like a mountain, right? But anyway, we have the rise over the run. That's the slope. That's the definition of it. It's how far we go up over how far we go over. So we can also say it's delta y over delta x. What does this delta mean? The delta is just a fancy symbol to mean change. So the change in y over the change in x. Well, what does that mean? Formula-wise, it means you're going to subtract y2 minus y1 because you're getting this distance right here, and then x2 minus x1 because you're getting that distance right there. So y2 minus y1 over x2 minus x1. Now that's just review for you guys because you did this earlier and you did this in Algebra 1. Now, just to review again, if you have a positive slope, it goes from the lower left to the upper right. Negative would go from this way to this way, and then zero slope would be like this, with an undefined slope as being vertical. Another way to think of this is I can draw a line here. Let's see if the software is going to let me do what I want to do. And I can take my line, and here's horizontal. Your slope is 0, right? As you increase like this, it's positive. And the positive values get much, much, much higher and bigger until they're so big that they're undefined. And then the slopes start to go negative. This is negative large values, and as you get back to horizontal, you're going from a negative large value back to 0. Horizontal is a 0 slope. Okay, and that's what we had said over here. Horizontal is a 0 slope, and we could do this again. Positive, big until it's so big that it's undefined, then we start going negative, back down to 0. All right, slopes of parallel lines. Slopes of parallel lines, the slopes will be exactly the same. So the slope of the blue will be the slope of the red. That's parallel. Find one, and the other will be the same. Perpendicular will be opposite and reciprocal. So perpendicular will be opposite and reciprocal. So if you multiply the two slopes, you'll get -1. So basically, we're going to say, and they don't say it here, we're going to say, oops, this one is what I want, the perpendicular slope, and that's how we say the perpendicular slope. That's the symbol for it. We take the slope, and then we take the opposite. Opposite meaning if it's negative, it becomes positive. Positive becomes negative. And then the reciprocal. So we flip it. All right? Moving on. Over here, to write the equation of a line, we've got different formats. This is going to be your point-slope form right here. This is your slope-intercept, just remembering all these. And your point-slope, what you have here is a slope, and you have an x and y point. Slope, x and y point. And then to convert it to slope-intercept, you're just solving for that y. So you could start with here and convert it to there. All right? And then we've got parallel lines, intersecting lines. Coinciding lines would be exactly the same slope, exactly the same lines, or multiples of them. So to write the equation of a line, we have to first determine the slope. Then we use y equals mx plus b, or y minus y1 equals m times x minus x1, which is the point slope. Now, how do we find the distance from a point to a line? We have to do the perpendicular, right? It's the perpendicular distance. Now, partitioning segments, we had a whole worksheet on this, so I'm not going to go over this in this lesson. I have a whole other video on partitioning segments because it's quite difficult. So we're going to watch the other video. We're going to practice these in class as we did. We'll practice more, but this is another video just devoted to partitioning a directed line segment. All right, So moving on, and we'll practice more of these later. Over here, let's do some examples. So determining the slope of each line. For the first one, the slope, is equal to 0. They put it down here. So the slope of this is equal to 0. The slope of the next one, well, we can either use the formula. They told us to use the slope formula. You can count it, right? Either one of those things work. And what I mean by counting is you can just say we went down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, negative 4, 6, which is negative 2/3. But let's go ahead and use the formula. Negative 1, 1, 2 is this point. Over here, point C is at 2, 3, 4, 5, 1, 2, 5, negative 2. So the slope would be negative 2 minus 2 over 5 minus negative 1. In this case, you'll get negative 4, 6, which is negative 2/3. So the slope is equal to negative 2/3. All right, moving on, let's see what we have next over here to find the slope. We're going to use the formulas because that's what the directions said. Over here, this is 2, 0, and point F is at 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, 6, 3, 4, 5, let's verify, 1, 2, 3, 4, 5, 6, yeah. So the slope will be 6 minus 0 over 5 minus 2, and in this case you're going to get 5 or 6 over 3, so the slope is 2. I can't do math right now. 2 when I simplify it. All right, over here, did they ask for perpendiculars on this? But let's just practice a perpendicular. What if you needed to find a perpendicular slope to this? The perpendicular slope to this one would be 3 over 2. I take the opposite and I flip it. The perpendicular slope to this one would be negative 1/2. All right, let's do this last one. Well, look, the line goes up and down, so the slope is undefined. Okay? What's perpendicular to undefined, by the way? Perpendicular would be 0. All right, we need to graph, determine the slopes, and determine if they are parallel, perpendicular, or neither. All right, so here are the points they give me for I and J. I is 1, 0. J is 5, 3, 4, 5, 1, 2, 3. This is I, J. Okay. And the next one is 6, negative 1 for K. 6, 3, 4, 5, 6, negative 1. This is K. And 0, 2 for L. Okay, we need to find each of these slopes. So, the slope of the blue one will be 3 minus 0 over 5 minus 1. This gives me 3/4. The slope of the red one will be 2 minus negative 1 over 0 minus 6. This gives me 3 over negative 6. Are these parallel, perpendicular, or neither? And these are neither. All right, let's do the next one. PQ is 5, 1. 1, 2, 3, 4, 5, 1. This is P. Q is negative 1, 1. And that would be P to Q. Okay, and then we've got the next one, which is 2, 1. And that's point R. And S is at 3, negative 2. And this is S, and it looks like this. And let's determine what these slopes are. Okay, so the slope of RS is going to be negative 2 minus 1 over 3 minus 2, which gives me negative 3 over 1. And the slope of QP, or PQ, doesn't matter, is going to be negative 1 minus 1 over negative 1 minus 5. This gives me negative 2 over negative 6, which is 1/3. Now comparing these are opposite and reciprocal. So the slopes are perpendicular. All right, let's take a look at this last question. At a resort, the different ski runs down the mountain are color-coded according to the difficulty. Green is the easiest, blue is the medium, and black is hard. So we've got green, blue, and medium. Assume that the ski runs below are rated only according to their slope, steeper is harder, and that there is one green, one blue, one black. Assign a color to each ski run. Okay, so that's talking about these questions right here. All right, so we've got emerald, diamond, and ruby. So obviously, the biggest slope is going to be black. And when I look at these, this one is black because this is over 1. Okay, then we've got green is the easiest, and red is the second easiest. Sorry, I mean blue is the medium. Okay, so now let's take a look at these two slopes. All right, 4/7 and 5/8. Well, 5/8 is bigger, so this is going to be the blue, and that means this one will be 4/7 the green. All right. Okay, so thanks for watching. Hit that like and subscribe button. We'll do more partitioning segments in class. Make sure to watch that partitioning segments video, and I'll see you guys in the next video.